Hello, Godot users. This is Wizard of West March with another tutorial. This time I'll be talking about some of the tools you can use when you're debugging your scripts. Debugging is definitely as much art as science, and different people have different techniques. So, what I do may or may not work for you, but my hope is it will make you understand what tools are available and to consider how you can apply them. If what I do works for you, fantastic. I'm happy because the goal is to give users the tools to do better at writing code. Am I succeeding? Hopefully. But let's get into it. Alrighty, so here's our scene. We've got a sprite that moves from left to right, but periodically, based on this turn back timer, will jump backwards a bunch. So let's watch it in action. Zips across the screen and it never snaps back. Well, that's interesting. Okay, so let's look at the code. So we've got a counter. It starts at 0. It increments 1 every frame, not every physics frame. And then every time the counter gets to greater than equal 75, it resets the counter. It starts the timer, modulates the color so that we can get an extra indicator of what's going on. We await the turn back, which means the rest of this code will not run until this completes. Then it changes the color back to normal, moves the global position X back 200, and then after that it will increment it forward 3. So you'll notice here I have a print T. When you need to see things in real time and you don't want to stop with breakpoints, which we'll cover in a second, then prints are a very useful tool. People have differing opinions on them, but just keep it in your back pocket. I'm using print T because the way it works is you just give it a comma separated list of values and it will print them with tabs between. So we'll see it in action here. So zips across the screen. All right, so let's look. So you'll notice 14, 0.9. Okay, so here is our useful point. You have 75 and it's barely below 8/10 of a second left. And then it resets to 1. So because my computer is running frames so fast, since it's not frame locked, it doesn't have enough time to get down to 0 before it resets the timer, because when you call dot start, it's just going to restart. So if I lock it to the physics process in this case, which does run at a locked frame rate, and mind you, it can go down if you're going slow, so this is not necessarily the correct solution, but it shows off what's going on. Now when we run, you'll notice it goes, and it's also going slower, and now it's snapping back because it has enough time, because it's like there's probably a few tenths of a second before it would have reset. So now it's working, and we'll look. Let's see what it was at 75. So it had actually stopped since frame 60, and because there was no time left, and then once it hit 75, it started the timer again, because that's when we redo. So we do counter 75, we restart the turn back timer. So it snaps back and then it starts counting up again from there. One thing I will note while we're here, I am not personally a fan of putting awaits in process and physics process. Future frames will clearly still run because like you see it running here, it keeps moving forward and then jumps back. But the problem is, if you have something in process as physics process, you assume it's going to run in the frame that you invoked it. What I tend to prefer is I will tend to, let me come here, make a timeout, connect, and then we will plop that in there and remove the timeout, and we should see the same results. But importantly, we're not actually delaying this global position dot x plus equal 3, because, and like honestly, it should keep moving forward when we trigger the timer, and instead we're delaying that as well. So just keep in mind awaits in process and physics process can lead to very confusing code, which will cause bugs that lead you to debugging, which is why I'm covering it here. But yeah, so using print statements can help you see, like in this case, I needed to know how these two conditions interjoined so I could see that it was getting down to 0 so that it could reset. Whereas before, when we ran it in process, it was getting like 2/10 of a second before it reset the counter, and it never got down to 0. So that's using print statements, our first tool for debugging. Okay, so now we'll be talking about breakpoints. These are a useful way to see the state of the world without having to figure out, like, oh, I need to print this, I need to print that. You can look at everything that's generally available. So you will see here, I've got a different script open. It's the one attached to main scene. And I've got 2 breakpoints already set. It's this gutter to the left of the line numbers. I've got one on the setting my other value, and I've got one on test func. Technically, this lets you put it on any line, and when you mouse over, you'll see a faded out version. If there's not one already there, that tells you can click on it and you'll get that line. But it's lying to you a little bit. Lines like white space, like this function declaration, those do not trigger breakpoints because they're not executable code. Now, like 19 would, because that's a jump, basically saying I need to jump to where test func is. But the actual label of test func does not work that way. So let's go ahead and jump into the code. So you will see here we are on line 22 because, as I mentioned, line 21 will not go. And here let's take a look at this UI. So we've got our list of breakpoints. You see we've got the 2 here in main scene.gd. We also have character.gd, and we can double click to jump to that one. So you can look at all your different breakpoints. Okay, now then, let's look at the variables. So here you see we've got my other value. It's currently null because we haven't set it yet. And in fact, let's go ahead, debug, step into, jump to the next line. You'll notice now it's ABC. Members, you will always see self. That is basically the script that you're in. Click on it. Oh, I'm in Node. So you will notice now that here is all of the information. So like my value is 6. That's set up here. The export variable is not set, which once again we'll get into in a bit. So you can see like all your variables, including your exports, and that gives you access to tracking what's going on with all of this. And so globals, this also shows you where your auto loads are, so you can click on it and here's my auto load. We'll play more with that in a second. But if you just need to see the state of variables, you can do that. Now then, this is where things get really important. Stack frames. So this is the different function calls going back to when Godot invoked into the script. So you cannot chain back into the engine proper. But you'll notice here we're on test func. I double click and it goes up to my first test func where we called test function. It puts an arrow there, which I find a little bit weird, especially because it won't disappear. So you can do that. You can go all the way back up here. But interestingly, so notice now it shows the locals. Now I can see my value 2 that's set to 5, and I still get the members and the globals. So you can see at the point each of these calls happen to get to where you are, you can look at the variables and you can do a filter. So for example, I can type in Kara to get character. So if you have a whole lot of stuff, because it's like a really big function, use that filter to find what you're looking for. Like I said, you can go all the way back. See, I've got underbar delta because I did not use it and I didn't like getting the warning. So those are the basic ideas of how you can access and use breakpoints. So the last point about using the debugger is if you get a significant like fatal error, it will automatically stop at that point immediately. So you'll notice I've uncommented out this character.flip_h. So I run it, and immediately we get to an error. We're in the stack trace view of the debugger, and you see invalid get index flip underbar h on base nil. If you've watched my shorts, you've seen this error before. Basically, it is saying that it's null slash nil, and as you can see here, that is true. So, like, the simplest way to fix it is just attach a value. I'm going to show one more thing related before we do that. I am switching it to calling a function on the script for the sprite. And you will notice now we're getting cannot call method get angle 2 on a null value. So I think I talked about this in the short, but just be careful. Null and nil are the same thing, really. It's just the context. One is calling a method, one's accessing a property value. So, though, like we come here and we come up here and we got character, we drag it in and we remove the breakpoints. And we will run it. And now it just runs fine. So yeah, just keep in mind certain classes of error will just crash the game and immediately jump in. Others, you will actually see errors in the debugger window over here in errors, but they will not stop it. For example, I talked about in the navigation video how I don't recommend putting the get next point, I think it is, in the physics process, because in the first frame it won't work. That is an error that will not crash the game. It just hitches a little bit technically because it's throwing an exception. So make sure you are regularly checking your debug errors tab that nothing is breaking, because it, even if it doesn't stop the game, it is better to not have those errors. Alrighty, the last piece that we're going to talk about today is the remote tab. So we'll start up the game and we'll freeze it with the breakpoint just to make things a little bit easier. You will notice over here on the left where we normally have the scene tree, there is also now a remote. You click on that, you notice this weird root node, the auto load, and then your actual scene. So the way Godot works is, as a scene tree, any given tree must have one root. And because the fact that Godot wants to be able to attach auto loads and doesn't want to make them children of your actual scene, it makes a separate tree that it then attaches your tree to, along with attaching the auto loads. So that's why it looks this way, is it doesn't want to break standard tree structure. But you'll see here, now when I click on these different nodes, it gives me all of the information. So you won't necessarily see like the contents of the script, because you need to go into a breakpoint and access it via the what we showed in the last section. But if you just want to go look around and see like, oh, what's the position? Is the frame coordinates right? Is flip H getting set correctly? So you can just check all this different stuff from here. Like, let's say you are tweaking modulate like I did, you could make sure that it's getting set to the right value. This all lets you just see the wider state of the app beyond what's in your one script. And, sometimes it might be something indirect that's giving you problems, and this will save you a ton of pain in figuring that out. Alrighty, so we have covered how to use the debug window, how to use breakpoints, and cases where print is useful. Hopefully this has made it a little easier to understand how to track down errors in your own code, because this is a big thing that you will have to master if you don't want to just constantly ask other people for help. It'll make your journey into game development much easier. If you have any questions, as usual, post a comment, and if I do it in a full-length video, I'll give you credit. I hope you have a good day, and good luck with your games.